Attention, are you tired of your messy home? Does it make you stressed just looking at it? Are you wanting a more modern, minimalist look but have too much stuff? If so, we have the right product for you.
Elizabeth, please describe our project.
Alright, well, our project is an in-wall storage unit. It consists of 2 shelves that can be operated remote controlled with a keychain that is coded to each shelf individually. With the press of a button, each one comes in and comes out, and then as they come out, a photoresistor starts reading values and then tells the light either to turn on or stay off depending on how dark it is when the person opens the shelf.
When the shelf opens, this switch is released. Only then does the photoresistor read values. If it is dark when the shelf opens, the light turns on. This is what the shelves were attached to. You can see the RF receiver on this breadboard. When the transmitter sends a signal to the receiver, it activates the servos, which either go forward or backward, depending on what button you press. This is our cost analysis, and as you can see, all of the materials that we used in our product. For our lighting system, we used photoresistors and white LEDs. To make the shelves move in and out, we used an RF transmitter and receiver to tell the servos to move forward and backward into the shelf. As for the rest of the products that we used in our design, they're included on the list. What difficulties did you encounter working on this project?
Well, our biggest difficulty was figuring out what to use and what plan to enact. Our original plan was to use linear actuators to push the drawers in and out, but due to supplies limitations, we weren't able to go that route. So our second plan was to use gear motors, and we were able to maintain those supplies. However, we were not able to make the shelves go back in once they got pushed out with the gear motors. And the gear motors also just spun too fast, so the shelf would fly out at Mach 3. So that didn't work. So plan 3, which is our current plan, is using the servos and the robots from Engineering 120 to make them go in and out and just coding the servos based on specific movement. We also had multiple plans for the shelves. Our first plan was to build it ourselves, which that didn't get off the ground, literally. So after failing miserably with that, we tried to order a few different shelves, and we finally just landed on the one that we have now, which, didn't we just have that? Yeah, we just had that. So, yeah. What are some limitations of this prototype, and how could it be improved in the future?
Alright, well, some of our limitations would be the technology that was available to us. We didn't have some of the stuff that you might find with commercial kind of stuff. So we basically were kind of left with the means that we could use. So for us, that was the Arduinos and what Noah was talking about with the linear actuator and the gear motor. So yeah, basically if this was sold on the market, this could possibly have a better way of moving the box or the shelf. And some other limitations were another limitation was that this box that we used to store the shelves was not made by us. It was bought, and then we kind of just manipulated it with a knife. And so if this was sold properly, it'd probably get made to fit the shelves perfectly and have a lot of extra availability for space.
constructing our project, we used two disciplines of engineering, electrical and mechanical. The electrical components comprised of the lighting system and all of the wiring. The mechanical part of our project was the robot that we used to make the shelf go in and out.